kind of sorting algorithm we are going to consider. It's the selection sort. So selection sort, and you see the procedure to make this selection sort. And there are always inside the procedures to make a sort, there are always two loops. There can be different loops, but here we see that we have outer for loop and we have inner for loop. And this algorithm, if we run it, if we execute it, and if we pass some array to it, we have here the parameter, the array, we need to be sorted. So it means that the elements of this array will be in sorted way. So it will be start with the smallest one and end with the highest or greatest one, yes, the biggest one. So this will be done after we run this procedure. So we need to pass in some array, and when we run this procedure, the array will be sorted. And the algorithm iterates over the array over and over, moving one value to the correct position. So it selects the smallest unsorted value and swap it with that which was the smallest before. So the sorted portion of the array is at the beginning. We start with the beginning. And we have some pictures to understand how does it work, because it's very difficult to explain how does it work, and it is better when we see it in some figure. And we see this figure. We have the array. There are many different elements here. Yes, about 15, as I understand, or 20. And if you see each iteration, the red square, it is the smallest number. And each iteration, after each iteration, we have the smallest number at the beginning, at the right place. So if you try to catch this picture, so you see red square, it is always the smallest element, and it will be in the right place after each iteration. So the inner loop finds this minimum element or the smallest element and place it in the beginning. If it is the first iteration of the outer loop, so it will be placed just at the beginning of the just as the first element. Then we will move to the second element, and starting with this second element, we will try to find the smallest of the rest elements of the array. So each time it starts from the beginning, yes. So each time we have some smallest element almost at the beginning of our program. And we need to do it. We need two loops: the outer loop and the inner loop. So they are nested loop. It is nested loop. Yes. So we need to the outer loop to move to the next element and to start with this element to find the smallest of the elements. So it is selection sort or sort by selection. We try to select some smallest element and to move it to the beginning of our elements. So it's one of the sorting algorithms, but it is not very effective. So it is not very good for our computer and for memory too. So some more algorithms we will consider too. Let's look at this one. It is called bubble sort. And the main idea of this algorithm that we take the first element and we compare this first element with the next one, and if it is greater than the next one, they will be swapped. And then again, we compare with the next one, and if it is greater, we will swap them. So the greatest element after the first iteration will be at the end of this array. So, and the name of this sorting algorithm is bubble sort. Why do we use this name? Because it works like when we boil the water, the greatest or the biggest bubbles go up. Yes, so they go up, and then they just crashed, or how to say it, I don't know. So the greatest, we take the greatest and we move it. If we have it at the beginning, we move it up to the end, Yes, and the next one will be taken also, and it will be moved again if it is great. And again, we have here 2 for loops. So always, and in every algorithm of sorting array, we use sum of loops. Yes, not one. One is not. It will not sort. So we have 2 loops, and again they are nested loops. So the inner loop and the outer loop. And inside this inner loop, we check if the current element is greater than the next one. And we swap them if it is needed, if it is greater. We swap them. So we move this bubble, a big bubble, we move it, yes? And outer loop needed to repeat this because we need some repetitions to have the array sorted. So it is the most popular sorting algorithm among school children, school students, because they like this association with the bubbling water. But it is not effective too. It is not effective, and it is not good to use big array, to use this procedure to have big arrays sorted, because if we have a big number of the elements of the array, so it is not very good for computer again. And let's look at this picture, at this figure. So we can see that just the greatest one, compares with the next one and moves, and at the finished, the last element will be the greatest, and then we try to find the greatest among the rest, yes, and the previous before the last, it will be the greatest, and each time we must repeat it. So outer loop will repeat these comparisons and swapping. So we can see it in this figure, how does it work, and it's more understandable when we see it. So two loops, we need to do it again. And it is bubble sort. We see that we try to find the biggest bubble and try to move it up to the end. Okay, so if you have some questions, you can ask them, yes. And you must understand, how does it work? So the bubble sort, you saw it, and the selection sort, you saw it. So, and one more, it's another kind of bubble sort too, but it is enough for you to understand how works this one. So we are not going to consider this. and insertion sort algorithm. The insertion sort algorithm iterates through the elements of the array one at a time and places each new taken element in a suitable place among the previously ordered elements. So we try to find, to take each element and to compare it with the previous elements and to paste it in suitable place where it has to be placed. So the previous element must be less than the current, and the next element must be greater than current. So if we try to see and to understand it, so each time we have some element and we try to compare. The red element, it's just the current element, and it will be pasted inside the suitable place. Always we have red, and we try to compare it with the previous elements, and we move it, and place it inside the place it has to be there. So here the 2, it is the smallest, and we try to compare with each element before and place it in proper place. So each time we do it. And again, we have two loops here. The inner loop, while loop, it's always try to compare with the previous elements. Yes, it makes these comparisons, the inner loop. And the outer loop always takes this red element and try to compare it with this element, with the previous elements. Okay, so we have again for loop, the outer loop, and inner loop. Here we have it while loop. So it is better to have here the while loop. Okay, so let's move on. But of course, we have in PascalABC.NET, we have the standard methods, the standard functions to do procedures to do the same. So we have sort procedure. Just we don't need to use this long algorithm just to write this procedure, the name of it sort, and to pass a array. And that's all. A array will be sorted. Or it will be sorted here by ascending. So it will be from smallest to the biggest. And if we need to do it in a different way, so to have the first element to have the biggest and the last element to have the smallest, we need to use another procedure, sort by descending. And again, we must put inside this parenthesis the array, and it will be sorted. So we can use these sort and sort by descending procedures, and we don't need to use these long different algorithms. But as a programmers, you must understand that there are many algorithms to do the sorting, to do this sort, to do our array to be sorted. And we considered some of them, but there are many of them. Okay, so now here we see the example how to have to understand which time will be taken to do this or that sorting algorithm, to do some part of the task, for example. We can time in it, so it can be timing. So here we have the goal to calculate the time which will be taken to execute the algorithm of bubble sort. So we need to understand what time will be taken to do this sorting algorithm. And we see we have this procedure to make this sorting algorithm. bubble sort we use here, 2 loops, one inside another. And then we have the beginning of our program. We have here the array, and you see that the number of the elements of the array is rather big, 20,000 of them. Yes, so it will be a long time. It will take a long time to make this sorting algorithm. Of course, for us it's not so long, but for computer it will be a long time, and we need to check to see what time it will be taken to do it. So we can use this system date time now function, and it will return the time, the exact time just right now we have. And we store it inside this t variable. Then we call our procedure, my sort procedure, and we pass in our array. So it will be run. Yes, it will be run and it will be executed. And then we must do the same. We will be timing the current time. Yes, so we need note the time. So system date time now, and we store it inside another variable. So we have t variable before the sorting algorithm and t1 variable after the sorting algorithm. So we have two points of time. And we must compare them just to make this t1 minus t. So it will be time which was taken to make this procedure, to run this procedure. Yes. So here we have the result. And you will need to do it in your task. So it will be task number 9. And let's look at it. So we have this task. We have this task for 14 lesson and task number 9. Task number 9, let's look at it. We have it here. So you will need to calculate a time to execute the algorithm of selection sort and insertion sort, and compare them. Compare the time to execute these two sorting algorithms. And before this task, you have here this sorting algorithm. So you need to have procedure my sort, to have this bubble sort, and only one. Open this selection and to find it here. Yes, so we have sorting algorithms here and selection. So merging of two sorted arrays. For example, we have a task to sort the array which will be done of two arrays. So we have two sorted arrays, A and B. They are given, and we have it in our example here, in our code here. So the first A array is 1, 3, 11, 19. Then we have B, it's 1, 13, and 21. And we are going to merge them into another array. So we have C array, and here we have the concatenation of the arrays. So it means that we just have the addition of two arrays. And but the problem, the task to do this array, the resulting array, to do it sorted too. And we have this addition. So first elements, they are from A array, and you see it 1, 3, 11, 19. Yes, it is A array. And then we have added B array. So it is 1, 13, and 21. So it's B array. We merge merged two arrays, and we have C array as a result, and we can use this sort procedure to make this array sorted. But again, it is not effective, so it's not good for a computer. And we can do it another way. We can do it using our own algorithm. So let's look at this algorithm. Let's look at this code, and let's look at this example and how we are going to do it using this code. But I tell you that it will not work. So we need to find the error here. So again, we have two sorted arrays, A and B. They are given, yes, and we have here for A array, we have these elements 2, 7, 13, 18, 24, and 25. It's A array. And we have B array 5, 6, 14, 31, 39, 42, and 45. And we are going to have a C array. There will be the elements from A array and from B array. They will be together, but we need to have them sorted. And we have this solution, how to do it. And here we have, let's use the counter IA as an index of the first element of A array. So IA is the index of the first element of A. It's just the index, so it will be 0 first. And counter IB as an index of the first element of B array. And we need to compare if A element, the element of A array, is less than element of B array. We are going to have it as a C array. So we are going to copy it and to paste it into C. And then we are going to increase this index. So we need to move to the next element. So let's try to imagine this solution. So we use this IA and IB as the indexes of our arrays. Yes. So we compare, first we compare 2 with 5. 2 is less than 5. So we are going to have it inside C. So we put here 2. And we increase, here we do it. So we put here C of IC is element of A, yes? So we have it here, we paste it here, and then we increase the index of A because we need to move to the next element. So here we have 7, and we are going to compare it again with this 5, with B element. If it is less, but it is not the less, 7 is not the less of 5. 5 is less. So we have else clause here, because A is not less than B, so it will be greater than B. So we are going to set B element to C. So this 5 will be here. It will be here. And we are going to increase the index of B element. So we have the next one. And again, we do it inside this for loop. We repeat it, repeat over and over. And we compare 7 with 6. Yes, we compare it. It is not less than 6. The A element is not less than B element. So it will be again else clause. And the B element will be inserted into C. Yes, 6. And we have this line. We must increase our index. So we increase it. We increase it. Okay, and again we do it. So the next will be 7 compared with 14. And 7 will be set to C element. and the index will be increased. Then we are going to compare 13 with 14. 13 will be less and it will be here. But as you understand, we have sorted array. We have it here, yes? So in C we have 2, 5, 6, 7, 13, and they are from different arrays, from A and B, and they are mixed, but they are sorted. So from the first look, we understand if it is that it works well, it works correctly, but it is not. So let's look. Let's continue to consider it. So 13 and 14, we put 13 and we increase the index. Then 18 will be compared with 14 and 14 will be less. So we will have here 14 and we will increase the counter, the index. And then we will compare 18 with 31 and 18 will be less. And we will increase, we will move on. And 24 will be compared with 31 and it will be less. So here we have 24. Then we increase the index. 25 will be compared with 31 and it will be here, 25, because it is less. And then we need to increase our index. But we have no any elements here. Yes? So how can we compare and how can we increase it if we don't have this? And these elements will be just lost. We will not have them here. We don't have to compare with something. So this algorithm is not perfect. It is not does not work, because we need here so-called barrier. Barrier, it means some great number, some big number here, just to continue the comparison. But it is always will be the bigger. So for example, we will have here 1 million, so some great number, some big number. It's no 1 million, it's for example 1,000. 100,000, yes? So some big number here. And if we are going to compare, the B elements will be always less and they will be added here, yes? So it will be 39 and then it will be 42 and then 45. And of course, we need to have extra element inside B, because there can be another elements here with another values, and the same situation can happen with B. So here we need to put something big too. So we call it barrier. To have this algorithm working, we need to have these barriers inside A element, inside A array and inside B array. So if we see the same elements just at the beginning, and we have here this number, some great number, it is not so big, but it is bigger than each of the elements of our array. Yes, so we can put it here. We can set this element to this number. It is bigger than others element. And we have these barriers, the two barriers, and we need extra index to have extra index for this element. So extra element, yes, and to store there this big value. And if we will see this algorithm of merging of two sorted arrays, we have here it as a function which is called merge, and which will accept from the main program two arrays, A and B arrays. It will be waiting from the main program these arrays, And another two integer values, they will be the extra places, extra elements. So it's the numbers one greater by one than the number of the elements of A and B. So n is how many elements must be inside A with extra element, and m is how many elements with barrier must be inside B. And we have here the values, max value of integer, and again max value of integer. So some big number, the biggest among integer numbers, will be set to A of n, and the same will be done with B of m. So it will be the barriers. And of course, we must use the result of this function will be array of this merged A and B arrays, and it will be sorted. And we must set the length of this array, set length. So how many elements there will be? There will be m plus n, because we will have the elements of A and the elements of B there inside this resulting array. And this the same algorithm as we had in the previous slide. So this one, yes, it will be the same, almost the same, but we don't have a C array. We have it as a result, because it will be a result of our function, and it will be returned to the main program, yes? So it will be stored inside as a result, and it will be returned when our function will be called. So here we have this array as a result, and it will be printed. But it is the same. So if A is less than B, if A element is less than B element, we store it inside C element, and we increase A index of A element. And if it is not, if A is not less than B, so the same will be done with B. So B element will be set to C element, and B index will be increased by 1. So this algorithm is more effective than that one when we just have the addition of two arrays and just sort the resulting array. So this is better. This algorithm is better. And here we have the main program, we see it, yes, and we have A array, B array, and we set the length. The number is greater than the initial number of the elements. We have here 4, and to have extra element, we set it to 5. And the same for B. To have extra element, we set it to 4 instead of 3. And then we call this function, we pass in this A array, we pass in this B array, so they will be here now, yes. And we pass the indexes of the last, yes, so it will be like indexes of the last element. So 4, it is for A elements, for A array. So we start with 0. So 0, 1, 2, 3, and 4 for extra, for barrier. Yes, so we need 4. Oh. And 3 for A, because we are going to start with 0, 0, 1, 2, and 3 for barrier. So we need to put here 3. So it will be inside N and M, and we have here 4. So it will be the 4th element, and it will be the barrier, so some great number. And here we have 3, so it will be the barrier, some great number. And this algorithm. And But we can use, instead of this algorithm, of course we can use this algorithm. It is good, it is correct, and it is rather effective. But we can use this method. It is a standard method, and it is inside the syntax of Pascal ABC.NET. So we don't need to understand how does it work, but it works not very bad. So it is also effective, but maybe not so effective as the previous one, but it is effective. And we have here the code, how does it work, but we don't need to consider it. We can use it. We can just use it in our programs. So we have, if we are going to have I'm sorry, it's binary search. It's not this. So if we are going to search something inside a array, to search x, so x, it means some value, for example, some number, we are going to search it inside this a array. We can use this standard method. And here this, how does it work? Yes. So to find the index of this element inside the A array, we can use this standard method, and it will return the index. So if we have, for example, in A, we have 1, 3, 2, 6, 5, and we are going to search x equals to 2, for example. So this binary search will return 0, 1, 2. So it is indexes, yes, indexes. So it will return 2 because the index of 2 is 2. So this method will return this index. But if it is not found, if it is not there, if, for example, we are going to find 7, and we see that there is no 7 inside our array, so it will return something less than 0 with minus. So we can understand if it was founded, it will be the index, and index is positive. And if it is not found, so it will be less than 0. The result will be less than 0. Okay, so now you are to do these tasks, task number 10 and task number 11. Let's look at them. Look at them in our website. So here you can just to see one more time this example of lab 8. It's a good example because we don't have it inside our presentation. So how to find some number? Yes, to use this binary search. We used here this binary search, and we try to find some value inside it. And we should output the index of n number. So some n value, and we should output the index of this value inside our array. Or to output there is no n, so there is no this n number inside our array. And we have here the code, how to do it, the example. And let's consider it because I don't have it in our presentation. So we have array. They are generated, randomly generated, the elements of this array. So there will be 10 elements, and we are going to sort them, then to print them out. And then we try to we ask user to input n value, so some number, to search it inside our array. And we use this method, binary search method, to return the index of this element inside a array. And we check if it was found. So the index, I'm sorry, there is a error here. If index is greater than 0, so we are going to print out the index of n is index. And if index is not greater than 0, so it wasn't found. So we are going to print out there is no n. So it's just as an example. Right now you can do task number 10. And what we have here, calculate the time to execute the algorithm of the lab before this task. So we see here is the merge algorithm. We considered it inside the presentation. So I have just explained it to you. Yes, and it is the same. So you need to copy this algorithm, this function, and to check how many times it will take to execute this algorithm. So to use the same system date time now, yes, as we have in task number 9. So you must understand what time it will be taken to run this function, and to compare this time with the time needed to complete the merging using standard sort algorithm. So we can use just this. Yes, C is set to A plus B and to sort C. And as you remember, I told you that it is a bad solution. It is not effective solution. So right now we can compare what time will be taken to do this bad solution and what time it will take to run this, to execute this merge function. The results will be the same, the results of the merging array, but the time will be not the same, of course. Yes, and we have here the resulting examples. So you are going to have the same in your output window. So something similar to this. And it's task number 10. And is it clear how to do it? Boys, I share my screen to continue my explanations about new topic. Yes, so this topic will be not included into these tasks I've said about, but you need them. You need this topic just because it's our topic. So I will explain it for you. It's just a bit later. Yes, here we have it. Not this. About the lists. So list is a kind of dynamic array, yes, but the size of the list can be changed during the program execution. So here we see some examples of definition and declaration of the list. And the first line here, it is, we have the variable L, and the variable L is a new list. So we have a new keyword, and we say to compiler that it will be list of integer type. Here we use this alligator brackets to have the type of the list. And type can be different. It can be of real type. It can be array of integers or array of reals. So it can be different. Char type. And here we have a list of integers. It is only declarations, yes, and we have no any elements inside it, but we can use short definition when we have when we say that it will be the list, and we have the elements of the list at one line, inside the same line. So we have var L, and then we use this LST keyword to say the compiler that it will be the list, and inside this parentheses we just place our elements. So they are the elements of the list. And we can use another way to do it. And here we have 3 examples how to do it different ways. We can make the list from the array. To get it as it was the array, we can see it, yes, so it was the array of some elements, and before the array we use LST to make the array as a list, to have it as a list. And inside this L2 variable we will have the list of the same elements as this array had, but it will be the list, not array. And we can use random, so we can use some randomly generated numbers. They will be the array also, so it will be 5 of them, and they will be generated in the range from -99 to 98. And again, we place here LST keyword to make this array list, to make the list from this array. And we store it inside this L3 variable. So L3, if we are going to print it out, we will have these elements, but they will be the elements of the list. And in the previous example, if we will have print L2, we will see the same elements as they were inside this array, but it will be the list. And one more example, it's a bit strange maybe. So we have LST, and inside this parentheses, as a parameter of LST, we have L3, and L3, as we remember, it's some list. And here we put it like a parameter of this LST. So it means that it will be only one element of list, but this element will be array. So it will be the list of arrays, array. So each element can be the array. So one element we have, and it will be the array. And we see these double square brackets. It means that inside this list, it is the first square bracket, so it will be the list, and the end of the list is this closing square bracket. And inside this, we have only one parameter, or only one element, this one, but it is the list, not array. I'm sorry, not array. We have it as a list, yes. So it is the list itself. Just one element, but it is the list. Okay, so this just for you to understand how can we declare the list and how can we make it from the array. And let's look what can we do with these lists. So how can we add the elements to the list? We can use this add method. So we have a list, it's a variable L. We have a list, we make it from the array, and it was these elements inside this array, and we make it a list. So inside this L, we will have the same elements, and it will be the list. And we are going to add 5, just number 5. And then we add number 3 and 4. And also we can use this just addition to make the same, so it will be the same as add, we can use plus instead of add. And if we will print it out, so we will see 5, 3, and 4, and we did it using add, and 8 was added using addition operation, sum, to add this 8. So we can add, and of course we can iterate over the list. We can use for loop or for each loop to iterate through the elements of this list. So for loop, it's the first example. We are going to start with 0 index to L.count minus 1. L.count means how many elements there will be. And we are going to start with 0, and it will be the index, the last index will be minus 1, because we are going to start with 0. So the indexes starts at 0. And because of it, since we have minus 1. And here we are going to print it out, but we can do here something more, some different operations and different statements can be here. And also we can use for each loop, but here we can't change. If we can change the elements of the list, so we can change them just to iterate and, for example, to print them out or to check something inside this list. So X will be the elements of L list. And we don't need here to understand and to know how many elements there will be, because X will be iterating through all the elements of this L list. Okay, so we can use 2 loops to iterate over the list. And also here some examples. What can we do more else with this list? So we have a list 5, 2, 3. Yes, the elements of the list, and we can just print out if 2 in L. So in, we can use this keyword in, this operation. So we try to understand if some number is inside this list, is among the list values. So it will be printed true here, because 2, we have it here. Yes, so 2 is in this list. And also we can use multiplication. So it will be how many times the list will be repeated. So we have 5 to 3, and we do it twice, because we have 2 times L. Yes, so 3, and again 5. If we have 3 here, we will have another 5 to 3. So the same as we can do it with the, for example, slices, and we can use dot notation to print them out, as we can do with the array elements also. And what we have here, we can use concatenation of the lists. So a list plus some other list. Yes, we have another list here, 7, 6, 8, and we printed them together, so we will have as a result these numbers. So first it was our L list, and then we will add here this list. And there are many, some of the methods to use them use them working with lists. So insert method, we can insert some value X inside L list in the position of index. So int is the position or the index we are going to place this x, this value x. Remove it. So using this index also to delete element by index. So index is the element we are going to remove, to delete from our list. And remove range, so it can be some range of the elements to be deleted. And remove all, and we can use this lambda expression to remove by some rule. And we use this rule that we are going to remove all the elements which will be odd elements. So we can use here some condition using this arrow operator. Index of. Index of means that this method will return the index of the 3 value inside our L list. Find index, and also we can use some condition here, yes, some rule. So find index of the element using this rule that element must be greater than 4. And the index of the first element, which will be just using this rule, the first will be output, will be printed, the index of the first such element. Clear, just to clear, to make it empty, we can use this clear method. Reverse, it means that the elements of this list will be reversed. So from the end to the beginning. Yes, so the different way of we had it in the array, so you must know it. And to have the list sorted, we can use this method sort. So different methods for you to make different tasks. And we have some examples also. So the first example, the first problem, that we have the array of n integers and insert all even elements of the array into L1 list and all odd elements into L2 lists. So we have some array and there are different numbers there, and we must take only even numbers and to place them into, to add them into L1 list, and to take odd numbers and to place them into L2 list. And we have here this code. Let's look at it. So we have some array. It is randomly generated. It will be 10 numbers in the range from 5 to 24. And we have it here. Yes, we printed it out. Then we will have, we are going to declare L1 list and L2 list. And we say that there will be the lists, new list of integer type. And then we have the for loop for each loop. We are going to iterate over a array, so it is array. So we are going to iterate through these elements of this array. X will be the elements, so it will be 17, then 25, then 8, and so on. Yes, and we check if X is even. So we can use this dot notation and to understand if it is even. So is even method will return true if X is even. So if X is even, then we are going to add it, and we use this plus operator to add this X to L1 list. If it is not even, so it is odd. So we use this clause, else clause, and we add this X to L2 list. So inside this L1 list, will be all the elements which will be even, and inside this L2 list will be all the elements which are odd. And we are going to print them out. So L1.println and L2.println. So we will see even numbers and odd numbers here. Yes. So it is an example. And I see that we have not much time, but I hope you will do these tasks, but you will not have the time to do them. So I think that we are going to finish to finish our lesson, and it will be better if I start our Friday lesson with these two problems, just for you to remember what we had today, what we have today, and on Friday we will do these tasks. Yes. So I will repeat you this problem, and I will remember you. So not remember, just I will make the revision of this problem, and also we will consider these two problems, and then you will do these tasks. And I hope there will be a lot of students, because I see that today it's not very. I don't like these lessons when I have not a lot of you, and especially in the morning.